Hello, everyone, and welcome. Today, we're going to dive deep into the science of healing the brain, and our guide for this journey is an absolutely incredible review article from Dr. Mubin Mustafa Kiyani and his team. It was published in the prestigious journal Brain Informatics, and it really maps out the future of treating traumatic brain injuries. So, to understand why this research is so important, I want to start with a number. 69 million. Just let that sink in for a second. That's the estimated number of people worldwide who suffer a traumatic brain injury every single year. And because it's so widespread, researchers like Dr. Kiyani have a name for it, the silent epidemic. You know, it's called that because the effects are often devastating, but completely hidden from view, changing millions of lives in ways we just don't see. So what is it that makes this epidemic so incredibly challenging? And more importantly, what is science doing to fight back? Well, let's get into it. Okay, so let's be really clear about what we're talking about. A TBI, or a traumatic brain injury, is basically any damage to the brain that's caused by some kind of external force. And it's a leading cause of both disability and death all across the globe, which makes this research, well, it makes it absolutely essential. Now, to really wrap your head around how we treat a TBI, you first have to understand the two-part attack it launches on the brain, right from the very moment of impact. You see, the injury actually unfolds in two stages. First, you have the primary injury. That's the immediate physical damage from the impact itself. But what comes next is the secondary injury, and this is crucial. Think of it like a series of aftershocks, a whole cascade of inflammation, stress, and cell death that can keep damaging the brain for hours, days, or sometimes even years after the initial event. And this is where the story starts to get really hopeful. We're seeing this amazing wave of innovation. Technology is giving us this unprecedented new look inside the brain, and with it, brand new ways to treat the damage, and maybe, just maybe, turn the tide against that secondary cascade. So the first big hurdle is just diagnostics. I mean, it's pretty simple, right? You can't treat what you can't see. So figuring out how to accurately see the full extent of an injury is the absolute critical first step. And this is where advanced neuroimaging has become a total game changer. It's like a whole toolkit for doctors. You've got CT scans, which are super fast and great for spotting bleeding. Then there's MRI, which gives you incredible detail on the soft tissues. And you can go even deeper with things like PD scans and DTI to look at the brain's metabolism and its internal wiring. And get this, the progress goes beyond just taking pictures of the brain. Researchers can now spot specific proteins in the blood, called biomarkers, that can tell them how severe a brain injury is. Sometimes this can give them answers even faster than a scan. It's pretty amazing stuff. So you can probably see where this is all going. When you have better ways to diagnose the problem, you can come up with better ways to treat it. And the number one goal for a lot of these new therapies is to stop that devastating secondary injury cascade we were just talking about. And the strategies for doing that are getting seriously impressive. We're talking about neuroprotective drugs that literally shield brain cells from harm, anti-inflammatory drugs to calm down that damaging immune response, and even the incredible frontier of stem cell therapy to potentially repair and regenerate tissue. And what's guiding all of this? The growing power of AI to sift through mountains of data and help predict what's going to work best for each patient. But, that initial treatment, that's really only half the battle. The road to recovery is long, and as we're about to see, it really does take a village. And I'm not kidding when I say it takes a village. TBI rehab is the definition of a team sport. You've got neurologists, physical therapists, occupational therapists for daily life skills, neuropsychologists for the cognitive side of things, the list goes on. All of them working together, collaborating for a single patient's recovery. And just like we saw with diagnostics, technology is showing up in a huge way for rehabilitation too. It's making therapy more engaging, more personal, and honestly more effective than it's ever been. Just think about virtual reality, or VR. It lets a patient practice complicated real-world skills, like going to the grocery store or crossing a busy street, all within the completely safe and controlled environment of the clinic. And then you have these advanced robotics and exoskeletons. It sounds like science fiction, but it's very real. They can physically support patients, helping them stand, walk, and do exercises that rebuild those vital connections between the brain and the body.
Okay, so here's the real magic behind all of this. The whole point of the rehab teams, the VR, the robotics, all of it, is to tap into this one incredible biological process, neuroplasticity. That's the brain's amazing natural ability to rewire itself, to form new connections, to get around the damaged areas. It's kind of like building new roads to bypass a huge traffic jam. It is the very foundation of recovery.
So, where do we go from here? The review looks ahead to the future of care and asks how we can make treatments even better for the people who need them the most. And a huge insight here is that TBI is not a one-size-fits-all problem. The challenges are completely different for a child whose brain is still developing or an athlete at risk for long-term issues like CTE. The same goes for an elderly person who might have other health conditions or military personnel facing unique injuries from blasts. The care has to be tailored to the person. So the future is all about getting smarter and more specific. We're talking about personalized medicine, where treatments are designed around a person's unique genetics and their specific injury. This is all going to be supercharged by AI, by further advances in stem cell therapy, and this is a big one, by global collaboration, so everyone can share what they're learning and accelerate progress together. This remarkable review from Dr. Kiyani and his team really is a guiding light. It shows not only the incredible scientific progress that's been made, but also the urgent need to keep innovating. It leaves us with a final and very hopeful question. With all this new science and with a true spirit of global teamwork, can we finally turn this silent epidemic into a story of recovery?